Okay, so today we're going to be learning how to solve equations with variables on both sides. So in your composition book on the table of contents, we're going to start on page 19. Even if you didn't end up using page 18, go ahead and skip it. And let's start on page 19. Write small because the title is long today. Today we're going to be talking about solving equations with variables on both sides. Then if you'll turn to page 19 in your composition book, and you can title it section 2-4, which again is solving equations with variables on both sides. So far in Chapter 2, all we've seen is equations with variables on only one side. Today we're going to start to see equations that have the variable on both the left and right side of the equal sign. For example, 4b plus 2 equals 3b. So you're going to solve these equations in a very similar way. You just have to make sure that you move both of the variables to one side of the equal sign before you start to solve. It's easiest if you move, when you're deciding which variable to move, you move the one that's going to keep the constant positive. For example, in this problem, it would make more sense to move 3b because it's the smaller constant, so the variable is going to stay positive. So in order to move 3b from the right side to the left side, all I'm going to do is subtract 3b from both sides. Remember, whatever you do to one side of your equation, you have to also do to the other side. So negative 3b minus 3b cancels out, and I'm left with 0 on this side. 4b minus 3b is 1b. And so I'm left with b plus 2 on this side. Then to solve for b, all I have to do is take away 2 from both sides. So b is equal to negative 2. Again, if you need to check your answer, all you have to do is plug it back into the original equation and make sure that you get the right answer. In another example, 5x minus 2 equals 3x plus 4. So remember, the first thing you want to do is move the variables to one side of the equal sign. So you can either move 5x to the right or you can move 3x to the left. Like we talked about, you want to try to move the variables so that it stays positive. So in this example, moving 3x makes more sense because when I subtract 3x from both sides, I'll still end up with a positive variable. Positive 3x and negative 3x cancels out, and on this side I'm left with 4. 5x minus 3x is 2x, so now I have 2x minus 2 equals 4. Now to solve for x, I'm just going to add 2 to both sides, and then divide by 2 on both sides. So x is equal to 3. Here's another example. 1/2 multiplied by b plus 6 is equal to 3/2 b minus 1. So in this example, before you start moving around the variables to collect them all on one side of the equal sign, you want to simplify first. Always simplify first. So I have an opportunity to simplify on the left side. I can distribute the 1/2 to the b and to the 6. So 1/2 times b is just 1/2 b. 1/2 times 6 is 3. So now I have 1/2 b plus 3 equals 3/2 b minus 1. Now you can decide here whether you'd like to eliminate the fractions or not. I'm going to just keep them the same because they have the same denominator, so it won't be that hard to combine them. Remember, now I want to take the variables and move them both to one side of the equation. It really doesn't matter which way you go. However, it's easier if you keep the variable positive. So I'm going to take away 1/2 b from both sides, Positive 1/2 b and negative 1/2 b cancels out, so I'm left with 3 is equal to 3 halves minus 1/2 is 2 halves. Now 2 halves is the same thing as 1, so this is basically 1b. So 3 is equal to b minus 1. Now I'm going to add 1 to both sides. So b is equal to 4. Now let's check that problem since it had quite a few steps. When you check, you always want to plug it back into the original problem, because if you messed up distributing and you plug in your answer here, you're not going to catch that mistake. So to check, we're going to plug in 4 to the original problem and make sure that it works. So I'm going to do 1/2 times 4 plus 6 equals 3 halves times 4 minus 1. So 4 plus 6 is 10, and 1/2 times 10 is 5. So let's see if that's equal to what's over here. 3 halves times 4 is 3 times 4, which is 12, divided by 2, which is 6, and 6 minus 1 is 5. So now we know that for sure that b does equal 4. Let's do one more example like that. 3x plus 15 minus 9 is equal to 2 times x plus 2. Remember, before you start solving, you always want to simplify as much as you possibly can. So in this example, I can simplify on both the left and the right side of the equation. On the left side of the equation, I can combine the whole numbers. 15 minus 9 is 6. And on the right side, I can distribute the 2. 2 times x is 2x, and 2 times 2 is 4. Now that it's simplified, I want to collect all the variables to one side of the equal sign. So again, I'm going to subtract the 2x to keep my variable positive. So I'm going to take away 2x from both sides. And then to solve for x, I'm just going to subtract 6. So x is equal to negative 2. Okay, if you'll turn over to page 20 in your composition book, we're going to talk about the 2 vocabulary words that you need to know for this section. Okay, so here's the vocabulary word for this section. Identity is the first one. It's an equation that is true for all values of the variable. So basically, an identity is an equation where you could plug in any value for the variable and you would always get a true equation. For example, if you have 2c plus 7 plus c is equal to negative 14 plus 3c plus 21. We're going to go about solving this in the exact same way we have been. So we're going to first simplify each expression. So on the left-hand side, we can combine like terms. 2c plus c would be 3c. And on the right-hand side, we're going to combine like terms. Negative 14 and 21. So we see that 3c plus 7. So some of you might already be able to see that 3c plus 7 equals 3c plus 7 is the same thing. If you don't notice it yet, you can keep on going. To move the variables to one side, you would take away 3c from both sides. When you do that, they both cancel out, and all you're left with is 7 equals 7. So when all of the variables cancels out, like in this example, you're basically looking to see if what you're left with is a true statement or a false statement. Since 7 does equal 7, and that's true, that's how we know that this is an identity. Now, this is not the answer. Our answer when an equation is an identity is all real numbers. Now, what does that mean? What does the answer all real numbers mean? The answer all real numbers means you could plug in anything for C and it would still work every single time. So we could plug in 2 for C. We could plug in 10. We could plug in negative 1/2. Any number is going to work when plugged in for C. So our answer is all real numbers. And the way that you tell is that if all the variables cancel out and you're left with two numbers that are in fact equal, that's how you know it's an identity, and the answer is all real numbers. The other vocabulary word for this section is contradiction. Now, contradiction is the opposite of an identity. A contradiction is an equation that is not true for any value of the variable. So basically, a contradiction is an equation where there's no number you could plug in for the variable to make it true. For example, 4y plus 7 minus y equals 10 plus 3y. So to solve this, we would combine like terms on the left-hand side first. So 4y minus y is 3y. So we have 3y plus 7 equals 10 plus 3y. So some of you may already be noticing that it doesn't seem to make sense that 3 times y plus 7 would be the exact same thing as 3 times y plus 10. If you don't notice it yet, you would keep going. You want to move the variables to one side of the equal sign. So we're going to take away 3y from both sides. What happens here is that it cancels out from both sides, and all I'm left with is 7 equals 10. Now, like I said, when your variables cancel out, you want to look and see if the numbers you're left with is a true statement. So, does 7 equal 10? Well, no, we know that 7 doesn't equal 10. This is a false statement. So whenever you're left with a false statement, it is a contradiction, and the answer is no solution. The answer no solution basically means that there's no value of y that would work in this equation. So that's why the answer is no solution. So let's do a couple more examples like that, and then we'll be finished with today's notes. Okay, 8x plus 6 minus 9x equals 2 minus x minus 15. So remember, before you try to solve, always simplify. So what can we do to simplify here? We can combine the 8x and the negative 9x on the left side. So that would be negative x plus 6. And on the right side, we can combine the 2 and the negative 15, which would be negative x minus 13. So again, you're going to try to move both of your variables to one side of the equal sign. So to do that, we would add x to both sides. They both cancel out, and I'm left with 6 equals negative 13. So when you're left with only numbers and no variables, you need to ask yourself if the statement you're left with is true or false. So does 6 equal negative 13? No, 6 does not equal negative 13. This is a false statement, which means it's a contradiction or an identity. It means it's a contradiction, so the answer is no solution. That means that there is no number that you could plug in for x that would make this equation true. Okay, how about 6 minus 2x minus 1 equals 4x plus 8 minus 6x minus 3. Okay, always simplify before you solve. So on the left-hand side, what can you do to simplify? You can simplify by combining positive 6 and negative 1, which would be positive 5. And on the right-hand side, there's actually two things you can do to simplify. You can combine 4x and negative 6x, which would be negative 2x, and 8 and negative 3, which would be positive 5. Now you may already notice that these are the exact same thing, but let's keep going. Let's try to move the variables all to one side of the equal sign. So we would do that by adding 2x to both sides. When we do that, they both cancel out, and we're left with positive 5 equals positive 5. So now you need to ask yourself, since all of the variables canceled out, is that a true statement? Does 5 equal 5? Well, yes, 5 does equal 5, so this is a true statement, which means that the solution for x is all real numbers.